Corals, often referred to as the rainforests of the sea, are among the most diverse and fascinating organisms found on Earth. These marine invertebrates, despite their delicate appearance, have formed some of the most vital ecosystems in the world, creating underwater cities that are home to an astounding variety of marine life. Corals themselves are part of the phylum Cnidaria, which includes jellyfish, sea anemones, and hydras. However, unlike their more mobile relatives, corals are typically sessile, meaning they remain fixed in one place throughout their lives. They exist in colonies that can span vast areas, with individual polyps forming the structural foundation of a coral reef. The majority of corals are found in warm, shallow waters of the tropics, particularly in areas that have clear, sunlight-rich waters. Coral reefs grow in areas where the water temperature remains between 20 degrees Celsius and 30 degrees Celsius, and they are typically found at depths ranging from the surface to about 60 meters. However, coral reefs can be found in other areas as well, though they are less common in deeper and colder waters. The reason corals thrive in these warm waters is primarily due to their symbiotic relationship with a type of algae known as zooxanthellae. These microscopic algae live within the tissues of the coral polyp, and in return for shelter, they provide the corals with the energy they need to grow and reproduce. Through the process of photosynthesis, the zooxanthellae convert sunlight into energy, which not only fuels the coral's growth but also gives coral reefs their brilliant colors. Without this symbiotic relationship, coral reefs would not be able to grow at the scale they do, nor would they be able to support such a vast array of marine life. The structure of a coral reef is a marvel in itself. Each coral colony is composed of numerous polyps, tiny animals that resemble small, flower-like creatures. These polyps secrete calcium carbonate from their bodies, forming hard skeletons that accumulate over time to create the reef structure. As new polyps grow on top of the old ones, the reef slowly builds up over the course of decades, sometimes even centuries. Over time, these accumulated skeletons create the framework for the reef, which is often built up on top of submerged mountains or along the edges of coastlines. The most famous type of coral reef is the fringing reef, which forms along coastlines, but there are also barrier reefs, atolls, and patch reefs, each with its own unique formation and structure. These reefs provide a three-dimensional structure that is rich in nooks and crannies, creating ideal habitats for a vast array of marine organisms. Coral reefs are considered the most biologically rich ecosystems on the planet, accounting for roughly 25% of all marine life despite occupying only about 0.1% of the ocean's surface. The biodiversity within coral reefs is truly astonishing. A single coral reef can support thousands of species of fish, invertebrates, and other marine creatures. Fish, crustaceans, mollusks, and echinoderms all depend on coral reefs for food, shelter, and breeding grounds. Some species, like clownfish, have developed specialized relationships with certain types of corals, offering protection in exchange for cleaning or food. Other species, like sea turtles and sharks, also rely on coral reefs for their survival. The reefs themselves are the perfect environment for these animals to thrive in, offering food in the form of plankton, smaller fish, and algae, as well as protection from predators. Without coral reefs, many of these species would struggle to survive in the open ocean, where there is less shelter and food. Beyond the sheer diversity of life they support, coral reefs also play a critical role in maintaining the health of the ocean. They act as natural barriers, protecting coastlines from the destructive force of waves and storms. The physical structure of the reef dissipates the energy of incoming waves, reducing the impact of storms on coastal communities and infrastructure. Without coral reefs, many coastal areas would be more vulnerable to erosion, flooding, and storm damage. This is particularly important in regions where coral reefs serve as a protective buffer for small islands or densely populated coastal areas. In addition to their protective function, coral reefs also contribute to the health of the wider marine ecosystem by filtering water, cycling nutrients, and maintaining the overall balance of marine life. Their role in sustaining fish populations is particularly crucial for global food security, as many communities rely on fish caught near coral reefs for their livelihoods. Despite their importance, coral reefs are under threat from a wide range of human activities. Climate change, overfishing, pollution, and habitat destruction are the primary factors contributing to the decline of coral reefs around the world. One of the most significant threats to coral reefs is coral bleaching, a phenomenon caused by elevated sea temperatures. When water temperatures rise, corals become stressed and expel their symbiotic zooxanthellae, causing the corals to lose their color and turn white. This process, known as coral bleaching, weakens the corals and leaves them more vulnerable to disease, predation, and death. If the temperature remains high for prolonged periods, the corals may die, leading to the collapse of the reef ecosystem. The frequency and severity of coral bleaching events have increased dramatically in recent decades, with the Great Barrier Reef, one of the largest and most famous coral reefs in the world, suffering significant damage in recent years. In addition to coral bleaching, overfishing also poses a serious threat to coral reefs. Destructive fishing practices, such as blast fishing, using explosives to catch fish, and cyanide fishing, using toxic chemicals to stun fish, damage the coral reef structure and kill or injure marine life. Overfishing depletes fish populations, disrupting the delicate balance of the ecosystem and making it harder for the reef to regenerate. Furthermore, the use of fishing nets and lines can cause physical damage to coral colonies, either by breaking off pieces of coral or by entangling marine life. These practices, along with the overharvesting of marine species, have long-term consequences for the health of coral reefs and the species that depend on them. Pollution is another major threat to coral reefs, with both local and global pollution affecting their health. Nutrient pollution, primarily from agricultural runoff, can lead to the overgrowth of algae on coral reefs, smothering corals and blocking sunlight, which is essential for photosynthesis in the zooxanthellae. This algal bloom can also lead to oxygen depletion in the water, further stressing the reef ecosystem. Additionally, plastics and other debris in the ocean can physically damage coral reefs and entangle marine life. Coral reefs are also impacted by oil spills and industrial waste, which contaminate the water and interfere with the coral's ability to grow and reproduce. Habitat destruction is yet another threat to coral reefs, often caused by coastal development, mining, and tourism. As human populations grow, more and more coastal areas are being developed, often with little regard for the ecosystems that exist there. The construction of resorts, piers, and other infrastructure can cause direct physical damage to coral reefs, while dredging and mining activities can disrupt the delicate balance of the reef ecosystem. In addition, mass tourism can lead to trampling of coral reefs by divers and snorkelers, as well as the collection of coral and marine life for souvenirs. Even though ecotourism can be a source of income for local communities, it must be managed sustainably to ensure that it does not harm the coral reefs in the long term. The threats to coral reefs are urgent, and they require immediate and sustained action to prevent further damage. Scientists and conservationists around the world are working tirelessly to understand the challenges facing coral reefs and develop strategies to protect them. Marine Protected Areas, MPAs, are one of the most effective tools for conserving coral reefs, as they restrict human activities that are harmful to the reef ecosystem. These protected areas allow coral reefs to recover and regenerate, providing safe havens for marine life to thrive. Additionally, efforts to reduce carbon emissions and mitigate climate change are critical in slowing the warming of ocean waters and preventing coral bleaching events. Coral restoration is another area of focus for conservationists. In recent years, innovative techniques have been developed to restore damaged reefs, such as coral farming and reef rehabilitation programs. Scientists are also exploring ways to breed more resilient corals that are better able to withstand the stresses of climate change, such as higher temperatures and ocean acidification. These efforts, while still in their early stages, hold promise for the future of coral reefs and the many species that depend on them. Public education and awareness are essential in the fight to save coral reefs. By understanding the importance of coral reefs and the threats they face, individuals can make informed decisions that help protect these vital ecosystems. Reducing carbon footprints, supporting sustainable fisheries, and minimizing plastic waste are just a few ways that people can contribute to the conservation of coral reefs. In conclusion, corals are much more than just beautiful and colorful organisms, they are the lifeblood of marine ecosystems. Coral reefs support a vast array of marine life, protect coastal areas, and contribute to the health of the oceans. However, they face numerous threats from human activities and climate change, and their future is uncertain. It is up to us, as stewards of the planet, to take action to protect and preserve coral reefs for future generations. Through conservation efforts, sustainable practices, and global cooperation, we can help ensure that coral reefs continue to thrive, providing critical habitats and maintaining the balance of marine life for years to come.